All right, my loves, it is Wednesday, part 3. This graph is showing the growth of a garter snake population after it was introduced to a new area. So, as you might see, I have tons of eraser marks because I even needed some help with this, and I really had to think this through. So if you don't get it the first time, remember, that is okay. So this population is growing exponentially. So how would we find the growth factor for the population? We have to figure out what the initial amount is being multiplied by each time, right? So let's kind of analyze our graph a little bit. I was having a hard time figuring out what they were counting by over here, but since there's 1, 2, 3, 4 to get to 100, each one is 25. So if we're looking at the snake population for 2 years, here we would have 25, right? And 3 years, it looks like 1, 2, 3, 4, 125. And at 400, it looks like 625. So if we are using the pattern in our answers, so 25 times what here? Well, 25 times 5 is 125. 125 times 5, well, if you didn't know that, you could always say 625, the new, divided by the old, to see what we are multiplying by, right? So they're being multiplied by 5. So our pattern there for 1 year then, whatever 1 year was, we would multiply by 5. So what times 5 equals 25? 5. So we divided 25 by what we multiplied to get year 3, right? Instead of multiplying by 5, we divided by 5 to get back here. Explain how you can find the y-intercept for the graph. Well, we could set x equal to 0, right? That would give us the x-intercept, right? Or no? Remember, our x is at 0 here for the y-intercept, so that would tell us where it starts. So write an equation relating time t in years. So this would be time. So this is actually going to be t in years. And population p, so our y is the p. Explain what information the numbers in the equation represent. So we start with p. What was our initial? Well, our initial really looks like 0, doesn't it? But that wouldn't work. We had to say that maybe we just started Well, that makes it tricky, doesn't it? So when we have 5 to the 0 power, that really just gives us 1. So we could say our exponential growth is 5 to the t. So which year is it likely to reach 1500? 5 times 5 times 5. So that was 3 times 5. There was 4 years times 5. Ooh. So 4 years was 625, and that times 5, and there's 5 years. So between 4 and 5, right? That is exponential growth. Craziness.